Hi everyone, this is K1C from ECD here, and my roll number is 04M7. So today I want to discuss about the memory models as a concept topic under the subject electromagnetic waves and transmission line. So today, coming to the introduction, these are also called as a permanent magnet as considered about their ability to change the intensity of magnetization in the field machines and memorize the flux density level in rotor magnets. So rotor magnets are used in a motor where it works under the concept of magnetization and flux. So it can be built either as a variable flux or a pole changing machines. So these are the two machines are built based upon these permanent magnetic machines, and in both machine types the magnetization of permanent magnets can be simply varied by short current pulse. So only the variants of the short current pulse they classified into two as variable flux and pole changing machines with no need of permanent demagnetization current as in conventional internal PM machines at flux weakening mode. So also the memory mode is a unique machine concept that has the potential to find numerous applications in electric drives. As some changes made where it classified into another where it leads to many applications in electric drives like variable flux and pole changing machine in a similar way. So the demagnetization current flows through the stator winding supplied from the same source as the stator current. Here stator winding is a three-phase winding, means it is able to convert the AC current form to DC current form. So memory motors combine advantages of wound rotor machine, which is also known as variable rotor flux, with those of wide speed machine, means no excitation losses, means there is no loss of any field, and it results in the unique machine concept that has the potential to find numerous applications in electric drives. So as mentioned in before, these are memory motors which has small changes leading to many applications in electric drives. So here you can see the first machine which is known as variable flux memory motor. Here we can see the diagram which is cross-sectional view of fully magnetized variable flux memory motor. This is a memory motor which works under the principle of variable flux. As flux changes, the power and the rotation of this motor changes. So variable flux memory motors, also known as VFMS as shortly, are relatively new class of machine that affords one the ability to actively change a motor from the high torque or low speed device into a low torque high speed device through the online controller. So it can change the speed of the we can change the speed of this motor using online control where flux of this rotor changes. So here you can see the principle of operation of a variable flux memory motor. So it is defined as a tangential magnetized PM with N poles, mean as a red objects, and S poles as a blue objects. Here you can see drive flux noted as 5 max through the air gap into the stator. The rotor is built as a sandwich of PMs, soft iron gray and non-magnetic material yellow, denoted as yellow, all of them being mixtionally fixed to a non-magnetic shaft. So these are the material we fix on the under the memory motor, which works under the control of online control, and they are defined in different colors as non-magnetic material as yellow and soft iron as gray and S pole as blue and N poles are red. So here you can see the air gap between these materials as known as flux density B, denoted as gamma, and remnant flux density of a magnet denoted as Br, and D1 D2 are the permanent magnet width on the shaft and the air gap side respectively. So coercive force H, denoted as Hc, and pole pitch as a Tp, and pole pair number as P. So here you can see the formula for the maximum flux density, which is denoted by ratio of maximum flux density of a magnet, denoted as BR, and below formula. So another thing is steady state performance of a 6-pole variable flux memory motor prototype with varieties. So these are the subclassified thing of the variable flux memory means motors. So the prototype machine was built with a standard and 3-phase wounded stator and additional such coils used for air gap flux density measurements. So the prototype has 3-phase wound stator and additional such coils with some air gap flux densities. So it should be noted that due to some non-technical reasons, neither the route of ferrite or magnetic nor the stator winding could have been optimized in the prototype. So, and since the described prototype was the very first variable flux memory motor ever built, and its main purpose was to demonstrate the validity of the flux control principle. And nevertheless, besides clear demonstration of the soundness of the proposed principle, the prototype machine has also shown very good overall performance. So these can show the good performance. So you can see the graph based on the induced voltage and air gap flux density in the variable flux memory motor prototype for the full magnetization, and also the induced voltage and air gap flux density in a variable memory motor prototype at off magnetization. These are the two graphs described of a variable flux density motors under full magnetization and off magnetization. And coming to the place of memory motors in synchronous machine gallery. So it is variable flux memory is a unique among synchronous machine because it combines the advantages of a wound rotor synchronous machine, means simple control of induced voltage. It is controlled under the induced voltage, and wide speed synchronous machine means no excitation losses. So its key attributes are given in table 2. Here you can see the many attributes for the variable flux memory, like controllability of a back EMF, losses due to control of a back EMF, mechanical speed, and many other. So in which this machine is compared with other types of synchronous machines like wound rotor, internal PM, and surface mounted wide speed and reluctance machine. And the performance of a available flux memory motor makes it attractive for many applications in electric drives. So you can see the performance of different 3 types of machines, like stator and alternative drive, which are efficiency and starting current, machine size, inverter size, short circuit breaking. So these are the parameters which defines the efficiency of the 3 motors. So coming to the application part, these are used in traction motor for hybrid vehicles and power generators and many household and industrial appliances. So coming to the conclusion, it has been shown the variable flux memory motors possess 2 disadvantages over conventional PM motors. They can be easily demagnetized with short pulses of stator current. Thus, a variable flux memory motor combines the high efficiency of a wide speed machine with the air gap flux controllability of a wound rotor synchronous machine, and the load component of a stator current cannot influence the state in magnet. So here variable flux memory can be magnetized and demagnetized with the small change in short pulse current, and the load component of stator current cannot influence the state in magnets. So